Okay, so I was going to remind you that we've met before. Okay, you guys are the recent February entry in ComPro. So I think I met all of you guys at the welcome lunch event that we had at Agiro. So once again, I'm happy to get a chance to speak to you guys again. And this time talking to you guys about technology and specifically about modern agentic AI tools that we can use for software development that we should be more interested in this day and age of software engineering and software development. So we want to study how these AI agents have actually become the state of the art for developing software, right? Software engineering has changed dramatically. In short, everything in life is changing dramatically of late because of this two-letter word, which is like the big elephant in the house called AI, artificial intelligence. So we will learn how to use autonomous agents and how they are reshaping how software is built. Okay, so I set up a few slides here. Well, the slides turn out to be a lot. There are 64 slides here, but don't mind the quantities because I made it a practical. So I showed you all the screenshots. So that way, if you want to actually uh, operate, if you actually want to practice the technology that we're going to learn today, you can actually use the slides. The majority of the slides are showing you the tool in operation so that you can actually practice working with it yourself. Okay, let's get started with the wholeness of the presentation. So a summary. The world is currently witnessing rapid giant leaps in the development and use of artificial intelligence, AI, like I mentioned. That is the big thing that is touching the life of across all industries, especially software industry, right? Software development industry. But it touches medicine, it touches law, it touches business, e-commerce. AI is actually gobbling and changing the way life is going to be lived on this planet, and is doing that really, really rapidly. And there's a whole lot of excitement and at the same time challenges and concern, right? It's a whole fear. Sure, the big fear side is that who AI will take over all of our jobs, especially the software engineering job. But we will get that question is still under debate. So we will get a chance after I talk like this. I will ask you, okay, what do you think? Will AI take your software engineering job? Or for example, another pinpoint question will be, is it worth becoming a computer scientist or a software engineer these days? We will get an answer, but by the time we learn this tool, we get to the end of the talk. But in software development in particular, AI, artificial intelligence, is now going beyond just code generation. So this talk is looking at like I mentioned, the state of the art, today's practice, right? In the recent past, yeah, AI stepped in and we can use AI tools to generate code. That we're already doing even up to last year or last couple of years. Code generation, that's an old news now. But through agentic AI, which is another level of AI, we can now not only just generate code, we can have an agent, what we call an AI agent, orchestrate complex end-to-end workflows and do that semi-autonomously. And take note of the word semi here, right? Semi-autonomously, saying, okay, it's not fully autonomous. And it depends on how you want to examine what we mean by full autonomy versus semi-autonomy. Can it do it all by itself without any human intervention? Well, it depends on the circumstances, right? Certain tasks, we can say, hey, it can do those autonomously without requiring human supervision. But for the majority of the software production, part of the best practice, as we're going to learn in this talk, is that you require some human supervision, right? Which is where the role of the software engineer still comes into play. We can't trust this AI yet. Yet the state of the technology is not perfect yet. And that's one of the takeaways from this talk. That best practice, know that AI is not perfect. It will do a lot, it's got powerful capabilities. However, a human software engineer still needs to supervise and review what AI has created and improve it or accept it if everything is fine. That's what we mean by semi-autonomously. And we'll see how that in practice as we start demonstrating some of the capabilities of the agentic AI tools that I will show. So in this seminar, I intend to present just an introduction to how software development is done in this age of AI. Now, being an MIU talk right here in Maharashtra International University, and we're all about science of consciousness. So as you're learning in your SCI course, we want to connect this topic that we're studying in the talk today to the central idea of our personal consciousness, right? So the sense of consciousness theme that's related to this topic is that thought leads to action, action leads to achievement, and achievement leads to fulfillment. Okay, let me begin with the boring part. And I call it boring part because, okay, this is stuff that is quite likely that you already know about or we already are aware of. What is AI? Okay, but I wanted to start from the basement, from the ground up, build the talk from zero to where we're going. So I decided to start from this nitty-gritty question of what is AI? First of all, let's be clear about what that is, right? So AI, meaning artificial intelligence, is a field in computer science that focuses on creating machines that and systems that perform tasks that typically require human intelligence, such as learning, reasoning, problem solving, decision making. So that's totally clear. Let's not dwell too much on these, but these ideas are the foundation on which we'll build the subsequent ideas in the talk. But we should also be aware that AI has subfields, right? AI is the global idea, the general computer science field related to creating intelligent machines that can reason, that can learn, that can improve, and that can actually perform tasks that used to be requiring human intelligence. But the subfields that AI actually has, and the main ones that we're interested in, is ones like machine learning, right? Which is focused on systems that can learn from data without explicitly being programmed. And then a subfield of machine learning is deep learning. It's a type of machine learning that uses artificial neural networks to analyze data and make predictions, especially useful in generative AI, as we're going to see in the subsequent slide coming up. And then there's natural language processing, another branch of AI, another subfield of AI that is focused on enabling machines to understand, interpret, and generate human language, right? Again, that's also necessary in generative AI, where we will take the AI engine will take input as natural language, English or French, and then generate and predict an output result that it delivers as the answer to the user. And then another important subfield in AI that's quite exciting these days is robotics, right? This is where the area of AI where we're interested in creating intelligent machines that can interact with the physical world. So if you were watching TV like I do recently, there was an exciting display by China of their humanoid robots. So a swarm of robots that can actually perform acrobatics so accurately like it's human-like. Anyway, but those are the branches of AI that are really making the rage and really exciting for our world coming up for the future, or for things that are actually taking place, that have been taking place of recent and going forward. Now, let's folks zoom down now to how does AI affect software engineering, or how has it been affecting software engineering, and where are we at with regards to AI and the practice of software engineering. So AI has increasingly become an integral part of software engineering, transforming various aspects of the software development process, right? And that's what our focus of today's talk is. What is the state of the art? What sort of tools are available that AI makes capabilities in AI that makes it possible for us to create software, to engage in creating software in new ways, more effective ways, as we're going to see. So application of AI in software engineering, yeah, fundamentally is code generation. That's one of the applications, right? Generate all the code for us once we give it some specification, some design, and autocomplete. And all of those were already there. I mean, we've been using that for a number of years now. So GitHub Copilot, Google Gemini, the large language models that can generate content, can generate text, including code, particularly in the case of software development. AI can also be used in software engineering for the purpose of automating testing, right? Automated testing. So we can analyze code and have the tool generate the test cases and ensure that it covers all the edge cases, and it gives us a sufficient amount of coverage to make sure that our code is complete and is ready for shipping to production. Other additional applications areas in software engineering that AI plays a huge role in today includes bug detection and fixing, as we're going to see in my demonstration later on. Code review and quality assurance, AI can handle that easily. Project management and estimation, natural language processing for documentation, DevOps, including continuous integration, continuous deployment, CI/CD, right? So software production, workflow automation, DevOps, big deal. We're going to study that in software engineering further. But AI plays a role in that. However, there are some challenges in using AI in software engineering. So let's be aware of those as well. So there are some challenges and some considerations to bear in mind as software engineers in this age of AI. While the use of AI in software engineering offers numerous advantages, there are these set of challenges. One, the quality of data, right? AI could have been trained with poor, outdated data, and that may lead to inaccurate predictions and inaccurate code suggestions. So we should be aware that AI works on data that it has been trained on. If it's been trained on an old version of the technology, then we cannot expect it to produce the new version of the code that we expect. So we need to be aware of that kind of discrepancy and know how to manage it. The second challenge is AI can be biased and other ethical issues, right? AI models can have inherent biases from training data as well. And that's just generally speaking, not just limited to software engineering. And then integration with existing tools. Incorporating AI into existing workflows and tools can be complex. However, work in this area is going on, as we're going to see in agentic AI. Okay, we've made so many, there've been so many recent breakthroughs that AI tools that are fully integrated into the software engineering workflow are now very, very excellent, as you actually see when I actually show some of the demonstrations that I will show today. Now, that was AI speaking in general. Now let's zoom down to a specific aspect of AI called agentic AI. Now, what is agentic AI? Agentic AI refers to autonomous systems that can use reasoning, planning, and tool integration to achieve complex long-term goals with minimal human oversight. So it differs from generative AI. Remember when we say code generation, where you actually give it a prompt and it generates the code based on what your requirement is, right? So generative AI focuses on just generating content upon your request, whereas agentic AI can act independently to solve tasks by navigating multiple steps and adapting to new information and correcting itself if it goes forward and it actually made some mistakes. It will actually review its own work, replan, reprocess, and correct any issues that it finds. So that's more powerful, right? More autonomy and more complexities. It can actually do more than just generating code based on a prompt. That's agentic AI for you. And there are powerful tools that we're going to see. One of them that we're actually going to study today is the one from Anthropic called Claude Code. Okay, we'll see the various other options that exist as well besides Claude Code. So here are a list of, so why does it matter, agentic AI, right? Why do we care? How does it affect us as software engineers in today's AI age? Well, we create so many benefits that makes us want to be excited about this future or this state of affairs. First one is you can now write software faster. An application that could have been taking weeks or months or even years to create can be done within a few days, or depending on the size of the application, right, the requirements, but faster development time. Automation. With agentic AI, we can automate pretty much every aspect of the software development workflow. And then we have this benefit of reduced context switching. If you notice, in generative AI, we will have to be switching to the prompt, write some prompt, switching to the chat session, right? If we're using a chat interactive mode. Hang on, let me actually say do this later. But the idea of switching context is where you switch from your IDE to another tool to obtain, to have AI actually process your prompt, and then you copy the code and you bring it into your IDE. Or switch to another tool to have AI generated diagram. You look at the diagram and then you present a prompt to, you give a prompt to the chat, to the AI to actually generate code. But all those needs to switch context will no longer be necessary when you use agentic AI tools that can actually do all of the entire workflow, design, architecture, code production, testing, all within a single interface without needing us to switch. And all of that put together gives us a higher productive developer, right? 10 times more productivity or even more than that, right? Like I mentioned again, task for a developer that could have been taking days or weeks or months will be taking a lot less time. You have 10 times your productivity than we used to have. However, we should be aware that agents, right, AI agents, the goal is to amplify your capability as a developer, not to replace it. Like we mentioned, it's semi-autonomously that these agents operate. It still requires the human developer supervision to actually make sure that all of the code that has been produced or all of the actions that have been executed, the software that has been produced is good for consumption before we ship it to production. Okay. So a set of use cases for agentic AI, coding is a primary one, testing, DevOps, workflow, CI/CD, we can actually automate all of that using agents, documentation, security, which is very important, right? Here's an example of where we can deploy agentic AI to fix a bug, right? So agentic AI can do the steps, all the steps that we as humans used to do. Human software engineer, to fix a bug, we need to first of all look at the bug, understand the bug, check the logs, see where the error is, and then go fix it, and then rerun the test and make sure that the test is passing, the bug has been fixed. Agentic AI can go through those steps once we actually automate that process and present the workflow to the agent to actually do it. And then the direction is to have a multi-agent team. A multi-agent team will have a scenario where, okay, the software process, all those roles that we require in a typical software engineering team can all become agents, right? So a team of agents that has an agent architect, an agent coder or programmer, the agent tester, the agent reviewer, and the agent DevOps engineer. However, best practices need to be followed, right? When we're using agentic AI to do our software development, you should have human in the loop, right? So you can't have it just produce whatever it produce and you ship it to production. You run the risk of it being not of good performance, being not security. So we need to be able to have in place as part of our workflow of our process, software engineering process, you still have places where the human engineer should review what has been produced for security gaps or performance deficiencies, or generally just make sure that the quality of the software produced is good enough and ready for acceptable that we can actually ship to production. And then make sure that we maintain logging, just like how we used to do as human engineers. Yep. Maintain a log of all the action that has been performed by AI so that when something is not quite right, we can actually use the log to show us what it did and it'll help us know where it got it wrong. And then for security purposes, prefer as a best practices to run sensitive agent operations in a sandbox, right? Especially when security is involved here. Because agents have the capability to go out on the internet, fetch some code, execute it on your machine. And this code can be malicious. This code can be dangerous piece of code. So you want to use a sandbox whenever necessary, right? To be safe. And then always validate what has been produced to make sure that it meets the requirement before we can ship. So yes, the logical next steps in the future development of these ideas of agentic AI will typically you want to have agent native teams, right? Like I said, agent architect, agent designer, agent coder, right? So typical software engineer today, you should call yourself, you should be aiming to become an AI native engineer. AI native software engineer is probably the new term that we can call ourselves now. As you can imagine, developers out there in the world will be looking for, not developers, employers out there in the world will be looking for developers who are not just developers of last year or last decade or they'll be looking for developers who are now able to speak and use AI to enhance their productivity. So AI, and those kind of engineers are AI native engineers, right? And then another feature is for us to be able to set up a chain of a pipeline of autonomous operating agents, right? Agents that can actually work in parallel and for tasks that do not have to be done sequentially, create sub-agents to do tasks in parallel and actually set up a whole complete software development production pipeline from requirements to through architecture design to code production and delivery and ongoing maintenance. That's the future. Now let's zoom down now to specific practical tools. What are the options that we have to actually make use of these agentic AI tools in our software development efforts? Well, I have specified 4 here. There could be more, right? But these are the 4 main ones that are actually notable in the industry today, or in the in the industry today. So the first one that I mentioned here is OpenAI Codex. OpenAI makes a tool called Codex. Codex is their agentic AI tool that actually automates all of the software development process and workflow. Google has anti-gravity, which I have a version for myself on this laptop that I've used quite a few times. GitHub Copilot was always there, and I has actually added agentic capabilities of late, right? In the past, I was using GitHub Copilot, which is typically what's actually integrated into Visual Studio Code. If you use Visual Studio Code often, it's quite likely that you've used GitHub Copilot or you've used it on the web, GitHub Copilot, through Microsoft's Windows system or the browser. Now, the fourth one is the one that we're going to zoom in on. It's from a company called Anthropic, and they make a large language model called Claude Sonnet, Claude Opus, but they make an agentic AI tool capable of doing all of what we're going to learn about called Claude Code. So Claude Code is an agentic AI tool that will automate your entire software engineering process and workflow and give you like that those 10 times more capabilities, 10 times more productivity than your ordinary human developer can. So let's zoom in now to Claude Code. What is Claude Code? Beginning from the basic introduction. So Claude Code is an agentic AI coding tool, like I mentioned, right? It has the capability to read and understand code base, edit files, like a human programmer would do, right? Execute commands, like human programmers would do, and integrate with other IDE tools, right? Execute Git commands, check in code, check out code, write create pull requests. So it's fully integrated end to end, covers all the typical workflow for software development. Claude Code can serve as an AI-powered coding assistant that can build out application features. So you specify what the feature is, and it can fix bugs. It can automate various tasks in the software development workflow. Now, how is it available? They make it available through a set of formats, right? Multiple formats. The most common format is a terminal command line interface tool, right? Available for Mac, Linux, and Windows. I'm going to demonstrate the version for Windows that I have here. It's a Windows machine that I'm using here. But you can get it for Mac, you can get it for Linux. That's what that means. They also have it available as a desktop GUI application, but for now, the only available distributed version is for Mac. They're taking invites or they're taking requests for those who would like to have a version for Windows or for Linux. So feel free to go to the website and let me actually navigate to that website now. So Claude Code product can be obtained from this URL. And pardon me, I actually wanted to show a whole lot of, like I mentioned, I want this talk to be not just the slides, but the showing and the telling of things. So I didn't open all the windows that I want to open. So I'll be doing a lot of things in real time and showing a whole lot of things since we're recording it. So you can actually get hold of the video, watch it, and follow my steps and practice with these tools yourself. So here's the home of Claude, right? And the Claude Code product itself. So like I mentioned, the tool is available in those 4 formats, and you can obtain it from that web page. It's also available in web, but the web version is currently in experimental stages, and it's only available through the cloud service providers, through Amazon or Google Cloud Platform or Microsoft Azure. And then you can also install it as an extension or a plugin in your IDE, like Visual Studio Code or Cursor IDE, which is another agent native IDE, AI native IDE, or JetBrains IDEs, like IntelliJ. Now, once you have Claude Code, which I'm going to demonstrate in a minute now, how does a developer interact with the tool? Through natural language commands. You tell it instructions in English, and it goes ahead and it performs the operations that you're requesting. Okay, so beginning with obtaining the tool. To get started, you want to go get it, install it on your machine, right? So there are a couple of options for installing the tool. The recommended option here is to install the native binary, right? So go get the native application itself and install it on either through PowerShell. If you're on Windows, Windows PowerShell is one option. So run a PowerShell script, as you can see here, install .ps1, and it will install the native tool for you. Or install it through Windows command for those of us on Windows. Or if you're on Mac or Linux, or if you're using Windows subsystem for Linux, WSL, use the call command to actually run the script, right? And that's how you install it on Mac. Alternatively, if you do not install the native installer, you don't use the native installer, you can install it using a package manager like we all know, right? So for Mac, the package manager is Homebrew, so you can do brew install Claude Code. For Windows, if you have Winget like I do, you can call Winget install. Now, I will actually let you know that there's some considerations to be made for which ones of these two options to choose, whether to install native or install with a package manager. And there are pros and cons to it. The pro for installing native is when you install it natively, Claude Code itself updates itself because this is a rapidly evolving tool, right? They update it like constantly, almost daily. So as those updates gets produced, it gets pushed to your instance that you've installed if you use the native installer. So it gets automatically updated for you, which is good. We want that, right? We want the latest and greatest features in the tool to be available to us. So yeah, alternatively, if you install with a package manager, then you have to manually go out and be running the install yourself. You have to do winget upgrade, winget update if you know that it's an updated version of the tool. So those are the two things to consider to choose which one. That's why installing as native binary is recommended. Okay, but I already have it installed. Like I said, just run this command in your PowerShell or run this command in your command line tool or this one in your Mac terminal or Linux terminal. And once you install it, it appears like this. So it's a command line interface version that I installed. Um, so you open your terminal, pick a suitable shell. I'm using PowerShell for my purpose here. And you can verify that I do have Claude Code here by running the tool command. The command for the tool is the name, Claude. So Claude dash dash version will show me the version that I currently have installed here. Right, so I got version 2.1.49 and Claude dash dash help will show you a comprehensive internal documentation of the Claude command and all of the various options and subcommands that you can use. I was talking about the need to actually add, to basically just follow this instruction that you see on this slide, right? You want to add the path to the Claude install binary, which is this path right here that you see here, C users, my name, dot local bin claude.exe, that's the executable. Add that path, the bin folder, particularly the bin directory, add it to your environment variable. And I showed how on Windows you get to the environment variable applet to actually make that happen. So once you have it added, then you'll be able to execute the command from any folder location, from any directory on your local machine to start Claude, to actually operate Claude Code. Okay. Another important thing to note is the fact that to use Claude as an agentic AI tool, Claude Code particularly, you need to subscribe to a paid subscription. So you need to create a paid subscription account. And this is the link to go to. So go to claude.com/pricing. Go make an account for yourself if you do not already have one, right? And it's a paid, I mean, it's not free, unfortunately. They do have a free version. Well, let me go ahead and show you guys on my browser screen here, if I can make this. Alrighty. Okay. So on my browser window here, let me open a new tab. So they got the free offering for Claude exists as a large language model provides you free use through the web browser or through a desktop application. However, it offers you limited capabilities, right? Look at the list of things that you can do when you use the free version, right? The free edition, pay nothing. However, to use Claude Code particularly, which is the agentic AI software development tool, you need at least the Pro or the Max edition. And both of them are paid subscription editions. For the Pro, look at it, it costs $17 either for a month or you could pay for a whole year. Otherwise, if you go monthly, it's $20 for a subscription. But it is worth it. If you see how much this can do for a software developer, you want to invest that $20 each month to actually take the opportunity to experience the tool and make it your tool. Alrighty. So you sign up for a subscription, and once you have a subscription, then you'll be able to log in through the tool. And that's what you see in my next slide. So in my next slide here, that's weird. Okay, here it is. So in my next slide here, you actually start Claude. which starts a session of the tool, and then you log in. Let me go ahead and bring up my command line tool here. And let me go make so let me demonstrate the first basic capabilities of this Claude Code tool, Agentic AI tool, that it can actually make you a whole new project. Say I want to make a Java command line interface project. So I'll go make a directory for my project. Let me begin from there. So just go make me an empty directory so that I can initialize a new Java command line interface project. Alrighty. So I got a folder here called demos. So my first demo just wants to show that I want to create a products management command line interface app. Alrighty. So just an empty folder so that I can navigate to that folder in my terminal. So cd change me directly to that my folder. That's my workspace or something like that, right? So empty folder. Hang on, let me see if I can make this move like it did before. Alrighty, thank you, Mr. Zoom screen. Okay, so I just changed directly to that folder. That's all. There's me initializing a new project. I want to start a new software development project for a command line interface application. So you begin Claude here. You start a Claude session by just executing Claude. Execute Claude version. Just make sure that I still have it running. Yep, I still have Claude on my path. And then let's go run Claude in this particular folder. Again, notice that you change directory to the folder where your project is, because that is actually what the context. There's a concept called context. That's the context that you want to give Claude, that I'm working with the code base that's going to be residing in this directory. So you start Claude, an instance, a session of Claude in that directory. Alrighty. So when it begins, it tells you to confirm that you are happy with this folder, you trust this folder, it doesn't have malicious code, again, for security purposes. So I can confirm that by saying, yes, everything is fine here. And that's the interface, right? The command line interface for Claude, right? So it starts an interactive session where it prompts you now, okay, what do you want it to do, right? So like I mentioned, well, this is my first demo, just wants it to create me a new command line interface. And I do have the prompt already created for myself here. So let me just go ahead and copy that and paste it to Claude here, right? So create me a new Java command line interface application to manage products. A product should have a product ID, name, unit price, quantity in stock, date supplied. And let it make 5 products data records in an array and let it print out the data to the console. So you can see the instruction, like I said, you interact with Claude Code using natural language. You tell it your instructions in English, but you want to make sure, just like how we do normal generative AI prompts, you want to provide as detailed as possible specification for what you want it to do, what kind of application, what are the features, what are the requirements, what are the corner cases, right? But I kept this simple because, yeah, this is just, later on we'll see a full-blown web API or web application that we need to actually provide a complete specification document and then have it process or generate the tasks for us and execute on those tasks. That's the ultimate capability that I will demonstrate in my third demonstration. But in this first demo, let's go ahead and execute this prompt. So let it go ahead and whisk on it. Thinking. So while that's going, let me jump back to the slide. So it noticed that the directory is empty. Oh, by the way, before I switch over, right? It checks the current directory. It's empty. So do you want it to proceed? And I will say yes. And always allow access to this particular, from this project. So do you want to proceed, create Java source directory structure? Yeah, let it do that. That sounds like a great idea. So yes. And later on in my other demo, I will show an option that it has to actually tell it not to do things more autonomously, right? To not be prompting you for a little basic confirmation here and there, right? So all of these, I can avoid all of this, but it's nice to actually, okay, if it's something that you want to do carefully and you want to give it a step-by-step supervision, then you want to allow it to prompt you to confirm certain options and certain choices before you proceed. Now, do you want it to create the product.java class? I will say, yeah, that looks good. So it's assume that it's generated the content for the product.java code. product.java class code, yep, and it wants you to confirm that that is good. So yes, proceed with that, and it now creates now that class, and it calculates the next step. It can now create the main class, because I remember I tell it to make some 5 random data, generate that data, and then print out the data to the screen. So check what it has generated. It made 5 data of products for me. And then, yep, it can print out the products to the screen. So really simple program like this, the kind of program that if you're new in Java, in a course like the next course that you're going to take after this course called FPP, we will have you write programs like this and follow some best practices and follow some Java application command or Java application structuring packages and things like that. So it's finished creating my application, and the next step here is I want to execute some command shell commands using bash, right? So make a directory where it can now write out the compile code, right? It actually could compile those 2 source code, the product.java and the main.java, and write the .class files. So I'll say, yes, that looks good. Go ahead and write it to that base folder. Go to synthesizing. I like the prompts that it presents, or the comments that it makes when it's actually processing. Okay, so it's done that and it's executed the program itself to confirm that everything looks good and shows me the project structure. So you can see that this is stuff that as you're going to study in FPP, okay, we will teach you these, and you as a human engineer, you got to know these best practices to make your package structure, to create this structure for your code, right? Structure your code in packages, which is pretty much just folders. So let's go ahead and open this project in an IDE just to confirm that everything looks good. So yep, let me bring it up here from my folder. So there it is. So let's open that in the IDE, Visual Studio Code. And again, this is where you as a human engineer need to now take a look at the software that has been produced. Is it good? Does it require further work on? So another way that you can describe a tool like Claude Code, these agentic AI tools, they are like the junior engineer, the junior developer that you can assign basic tasks to, right? Basic repeatable tasks to actually do that with that, while you actually focus on the bigger ideas of architecture and design and performance optimization. But here's a product class that is generated. I mean, here's the project structure to start with. And looks all good, right? So instance variable, like I actually told it in my prompt, and constructor getter methods. And then here's the main class. Looks good. And then I told it to generate data, put in an array, and it did that. And go ahead and print it out. Okay. So let's move forward from these little basics, right? And we will now consider, what if code base already exists? So the rest of my slides, it just shows you, like I mentioned again, a screen-by-screen demo of what you will do when you start working with this tool, right? If you, after the talk, when you want to go practice beginning working with Claude. So logging in and things like that after you sign up for an account. So I will scoot past all of these steps and go to the next demo. Okay, but before we get to the next demo, there are certain concepts in working with agentic AI such as Claude that you want to know, right? Particularly Claude Code. The first one is session, right? A session in Claude Code represents a persistent, context-aware, and interactive coding environment where it maintains state, right? It needs to remember, hey, what is it working on, right? What are the files that exist? What are the files that contain whatever kind of code that it needs to edit, right? Including the conversation that you're having with it, right? The various instructions that you've given it, the file context, and the active processes within a specific directory. That represents a session. And a session is linked to a given directory or a set of directories, right? So including if you issue the Claude command and you execute it, that starts a session, right? It could be a new session if you've never worked on that particular project before, or it could be resuming an existing session. All you need to do is give it a switch that says, hey, Claude dash dash resume, and then you give it the session ID. So every session has an ID that it generates, and it presents that session ID for you to use in case you want to exit your session and then resume in a later date. But to begin a session, it's a matter of just executing that Claude command like you saw me do for that first demonstration. It starts a session, and a session is where it contains all the information that's going to work with, right? What is this project about? Now, there's a concept for managing session because the session contains a context. Now, what's a context? A context is its short-term memory, right? This is all the instructions that you've given it, all of the answers that it's giving you, what are the files that he has been working on, right? All of that falls within what we call a session context. And we want to maintain that session context because it has a limit, right? The AI tool puts a limit on how much information you can put in the context. And you don't want to exhaust the limit of the size of your context. The context, call it the context window. So Claude's ability to retain information and understand your project is fundamental to its effectiveness. So you want to actually make use of certain commands like compact when well, think about the session context management. The good news for us is that Claude Code itself helps us manage the use of the context window. So once we've given it so many instructions over a long period of time during a session, and it seems like we're exhausting that limit, internally, Claude automatically summarizes the context, right? Summarizes everything that it already knows from you about the project, removes any redundancy or any excess things, and frees up space so that you do not run out of context window space. Now, another key concept or item to note about the tool is we make use of a special file called Claude.md, a markdown file, which is a special markdown file that the tool uses to automatically read and include in its context. Okay, that's what tells it information about this project, right? And you can have multiple Claude.md files that will contain various information about various aspects of the project. So it's persistent data that Claude will read every time you start a session on a given project. It will read the information in this file and hold that in memory and use it to work on your project. Now we can create a new version of this file anytime we want by executing a command, /command called /init. /init will make us a new Claude.markdown file, and then we can put additional information that we want to be available to Claude whenever it starts working on the project. So /init is just one of the commands. Other additional commands that you can use are /clear. /clear will erase the short-term memory. So clear the context because I want to start a new task. And that's what we should, a recommended practice to actually do, right? Make it a habit to clear your context whenever you finish a given task. I finished working on the login feature. Okay, so I will not be referring to that anymore. So no need to let that all the information that you've provided to the tool fill up that context. So you can issue the command clear to free those information from the context and free that space so that you can now start a new task with new information. Compact, say, hey, I don't want to clear that short-term memory, but let it summarize it. The thing that I mentioned that it does automatically, now we can do it deliberately by ourselves, manually, by issuing this command. Compact, summarize all the old version of the conversation and still keep it and use just that summary for the future conversation as I go forward. The /exit, that's how you exit the run, evaluate, print loop, the REPL. So Claude operates as a REPL. What we call a REPL is what you see there. This is a REPL. It's a run, evaluate, print loop. So it's just a loop that's prompting you for, hey, what should I do next? You give it an instruction, it does that, and it comes back, what should I do next? So that's the REPL. So to exit it, you do /exit. And whenever you type /, it gives you an autocomplete for the available commands that you can execute, that you can run. So exit is how you exit the REPL. But exiting the REPL doesn't mean you've actually closed work on that project, right? The session is still there. It will show you the session ID so that you can resume that session by restarting the session and by running Claude again, restarting the REPL and then passing it the session ID. And then context, like we talked about the context. Context is the short-term memory where it stores all what it knows about a given project, including the tools that it can use for this project, what is the technology stack, and we can actually issue a command to see a visual view of what is currently under context by issuing the context command. So context will show you visually, these are the system prompts, how much of it that you're using, right? You can see in terms of how much of the resources that you're consuming so far for this session. What are the tools that I have? And you can actually ask it, right? For example, let me go ahead and say, what are the system tools that you have access to? And the system tools are, hey, things that, remember, this is an agentic AI that can reason and that can integrate with other tools like your bash tool or your PowerShell tool, right? Your Git command tool. So all of those things that we need as part of our software development workflow, Claude Code has access to them, and they will be presented as some of them will be the system tools. So this prompt will have it show me, give me a presentation of the tools that I want to be aware that it knows that it has capabilities of executing and making use of during while it's working on my project. So you can see that it's got access to some basic commonly used tools like the bash, right? You can read a file from the file system. It should be able to write a file, edit a file, right? It should be able to execute bash commands on the terminal. It should be able to work with tasks. My TED demo coming up will show you this idea of a task, right? Which is pretty new. They only released this just, I think, about a week ago or a couple of weeks ago, that you can actually give it a project specification and it will generate what are the features. You tell it in your specification, you tell it the features for the system, and it will generate the tasks and it will execute on those tasks all autonomously. And that was actually the highlight of my presentation, to be honest, when we get there. But additional tools, it can actually go out on the internet and fetch content from a URL using web fetch. It can search the web to get some information when it needs it. So those are system tools. Let's continue here. More about slash commands. So those slash commands, the commonly used slash commands that I present here in this slide are built in, right? They come with the tool. But it's got another additional capability that you can actually create your own custom slash commands. Commands that you want to be able to maybe issue to do some custom operation as part of your workflow as a software development team or as a software developer. For example, you want to create a command for it to be able to create this application specification requirements document. You want to create a command that you give it a name, spec out this feature, create a spec. So to create a custom slash command, all you need to do is create a markdown file for it, right? That will contain the instructions that you want Claude to execute. And instructions could include things like let it make a directory, let it actually call a Git, initialize a new Git repository, and then let it create some files, and then let it check in the code, and let it make a pull request. So all of those instructions go in your markdown file. And you pretty much want to save that markdown file in two options, two possibilities. If the custom command is only for a given project, for just that project that you're working on, so it is project scoped, then you store it within the project folder in a specially named folder .claude and a subfolder commands, and you create this markdown file in there, right? Alternatively, if it's a command that you want to use for multiple projects, right? And you as the user own that command and you want it to be available to you on your machine whenever you log into that machine and you're working with Claude Code on a project, then you store that custom command in your user home directory, which is what this represents. So you create that special name folder called .claude, and you can create a subfolder named commands, and then you create the .markdown file in there, and then it becomes your custom slash command. And let me go back and mention that the difference between these two options is the fact that for project scope commands, it's quite likely that you want to check in that command into your repository, right? Because this is going to be used by other team members on the project, right? So you will commit the command markdown file along with the project source other project artifacts to the Git repository that contains the project. The powerful command in the future lesson, I'll demonstrate how to create, show an example for how to create custom slash commands. I just didn't cover that in this talk for today. Okay, so this is my first demo that I've already shown, right? So I will just go past this, creating that simple command line application. That, by the way, it ran by itself, but we could go ahead and run it. So on my second demonstration here, I just want to show, okay, assuming you already have some existing project, which is a typical scenario of what will happen when you get a CPT job, right? You get hired by a team, and it's quite likely they already have a software project that they want you to come and work on, right? And there's typically this large code base, right? Depending on the size of the project, that they'll just assign you, come and work on this project that they call e-library, right? It's a library for a city or a library for a school. and they've built it out a number of features. They just want you to go and implement a new feature or maybe go fix a bug, right? So let me go ahead and close this project for now and open that new one. And then let's examine how this agentic AI Claude Code tool can help us with working and understanding, or understanding and working with an existing project. Let me say later. I'll just close that. Alrighty, let me close that. That's consuming space as well. So I got my existing project here, which again, I use this project as a demo project in the software engineering course, which we're going to work on with. So let me, where's my demo? Yep. So that's it in here. So this code base already exists. Can Claude Code help us understand what is going on in there with thousands or hundreds of thousands or millions of lines of code that without a tool like Claude Code, you have to actually spend time. I mean, from my personal experience, it used to be a case where when they hire you as a new engineer in a project like this, you could spend the entire first month not being able to work on anything because you don't understand the design, the architecture, the technology stack, and right, the design details about the project. So they give you time. The entire month could just be get familiar with the code base. Okay, with agentic AI tool like Claude Code, no, you don't need the entire month. You can have Claude Code go explore this project, all the millions of lines of code, graph out or diagram out the architecture, diagram out the domain model, give you a good, clear insight within a short time about the project. And since I'm running out of space here with the computer issues, I'll just go ahead and show the result on the slides. So yeah, you have manually, you will have to read all of the code that we see here in this ID, open it an ID and run it and explore it and read lines of code, and it'll take you an entire month or more. However, you can actually ask Claude Code to load that project in its context, right? And issue a basic question, a prompt that says, hey, explain what the code base is about. And this tool will go through, read the entire code base, and tell you what this project is about. It will discover and let you know that this is the Fairfield City Library Management System. It's a Spring Boot web application for managing library resources, right? Books and publishers and all of that good stuff. What it does is it's a multi-user library management application with two distinct areas. So basic prompt like that goes through and discovers lots of things about the project, including the technology stack, then you can go ahead and tell it to diagram out the architecture, including the domain model, or you can pick a particular package like the model package, the package that contains the domain model classes, let it structure it out and create an ASCII diagram for me. So draw me an ASCII architecture diagram for the model package. And there we have it, right? So it draws out this ASCII diagram, shows you what classes are included, what interfaces, how they are related, the kind of diagram that you probably want to ask the development team or the designers in the team or the architects in the team to give you. They don't need to give you that. You can generate that from the code using Claude Code like this. So that's another powerful capability for agentic AI tool like Claude Code, right? It makes it quicker to onboard. Well, this whole process is onboarding a new engineer in the team. Okay, we don't need to spend an entire month or longer to actually get them familiar with the code base, right? To understand the code such that they can be able to implement a new feature, they can be able to solve, fix an issue. So Claude Code makes that really, really simple, really, really easy, and gives you that powerful capability. Okay, that's for that second demo. Now, like I mentioned, the third demo is pretty much where the state of the development is, right? Where we actually want to make a whole application and we don't have to make it from scratch, or we don't have to actually make it ourselves. Majority of the code that are boilerplate, well, this is all a diagram. So the rest of the slide is a diagram. And yep, machine is running out of memory. So at some point, it's not able to show the image on the slide. But let's go straight to the okay, so our second demo is just exploring existing code base, right? This third demo, like I mentioned, is the typical practice as a software engineer today that you actually want to go about. It is called spec-driven development, right? Spec-driven development sounds like test-driven development, but where we go about developing software by just creating the specification as completely and as detailed as possible, right? The better, the how well done your specification is will determine how well Claude will execute on the features and produce you good quality software, right? But we'll see how that. I'll go ahead and show you how that is done now with Claude Code. But yeah, so the scenario here is in this demo where I want to use a dental appointment management system, a web API, just the backend, right? For as an example. So using Claude Code, we can apply agentic AI to orchestrate the entire software engineering workflow from requirement specification through architecture and design and code generation, including testing. So we will make use of this new concept. Like I mentioned, this was just only released in the version update for Claude Code from, I think, last week. So just to have the tool, right, give the tool a head start, right, I will go ahead and I've already gone ahead and created a skeleton of the application. So it's a RESTful API. I'm not sure what you guys' technical background is, but in this program, especially in software engineering, you're going to study Spring. So Spring is our technology stack. Spring is our enterprise application development for Java stack, a framework that you can actually use to build RESTful API or full stack web applications. So I've already initialized an empty Spring application for my purpose right here. It's in this folder called Dental Appointment Management Web API. And this is just a plain vanilla Spring application. Let me open that in a new Visual Studio Code Insiders. I can close this one now so I can free space again, not consume too much space. Close that folder. And close this instance. Alrighty. Let me go ahead and open this already initialized Spring Boot project for my dental appointment management web API. And if you're curious about, hey, how do we initialize a Spring Boot application? That's simple. You have various options. I use this web page here, start.spring.io. It's called the Spring Initializer. Choose the options and initialize one for yourself. However, I should also make the point here that I'm just deliberately choosing to give the tool a head start that, hey, I know what the application should start with. So I want to do that ahead of time and then let it now just work on the features that I'm going to provide in my specification. Alternatively, it's got capability to actually start the application, initialize a new application for you, just like I will show that it can make a Java command line application. Yep, it can make a Spring Boot application if you include it as part of your specification, part of your instructions, right? No need to restore. Okay, but so I won't go through the steps of creating a new Spring Boot project or teaching about Spring. It's not about Spring, it's about Claude and Claude Code. Okay, but that is the project that I wanted to work on. Therefore, I need to navigate to that project folder and make it the context of my next Claude Code session. So again, I will change directory to that location. Let me go ahead and copy that. Copy this path, this address. Go to my command line Claude Code. I could CLS here. I think I already have a session still going on here. No, I can exit this one. We're done with this one. So go ahead and tell it to clear. Remember, clear the context. And change the session, right? Totally exit so that I can start a new session, CLS, or just exit this whole instance here so that I can CD now to this new path, this new project, and confirm that it contains my initialized set of files for a Spring Boot project, right? But make this the context, the project, that Claude Code, new Claude Code. So start a new Claude Code session right here, right? And this time I want to execute Claude Code such that let it go ahead and feel free to produce content using HTTP to obtain content from the internet without stopping and worrying about asking me to confirm, right? So I'll issue a switch, an option that says dangerously. You can see that dangerously, and it's danger, but again, you're sure of what you're doing. There's no danger. It's safe, but let it skip all permission. Don't be asking me for permission to download one thing or the other from the internet. Otherwise, my workflow will be slow. I want it to work as autonomously as possible, fast, right? Do all of these within a short time. So start this session with that mode, right? This is running with a bypass permission on mode. So it's now ready to take instructions from me. Now, like I mentioned, we're going to use a mode called planning mode to do this project. This project, we want to build out a complete set of features for the dental appointment management system, right? We want to build a web API, let it use, it will discover that it needs to use Spring, even though, yep, we've already initialized Spring for it, and it will discover that, yeah, you already have Spring for me. Okay, fine, I'll work with this one. But we will tell it the tech stack. We will tell it whether it's to execute tests, what tests to execute. We will tell it the endpoints to create. We will tell it all what you will receive as requirements as a software engineer from the designer, right, from the architect. And then how do you present all of that specification to it? You create a document called a product requirements document. Let me bring one over here, one that I've already defined. So this is where the work is. Oh, by the way, let me show. This is the raw requirement, information from the customer, the hospital or the dentistry. Says, hey, they want a system that does all of this. As we know in traditional software engineering process, you as the analyst or the architect, right, or the lead engineer, you have to digest all of this information about the dentist surgery, about the dentist, the patients, appointments, and then you will come up with a design, and then you will now implement that design. But for this workflow, for this particular AI agentic application, we want to use AI agentic mode to actually do the job. We will create a file called spec.md. And that spec.md will be our product requirement specification document. So let me go ahead and add that to my project. So where you put that file is on the root of the project. So make a new file for me here called spec.md. Alrighty. And then this file will contain the project specification, the application specification as a markdown file. So this is it, all of it here. Let me copy all of that. So you can see it's a detailed specification that will tell the AI tool what this application should do, what it's about to start with, right? So a title here, and then this is the product requirement document, version it, date it, who's the author, executive summary. All of this will form part of the project documentation, as you can see, right? This is what typically we're already doing this in software engineering manually as system analysis, right? Analysis and design, requirements analysis. Okay, we're specifying those requirements, but this time we're creating it as a markdown file that can be ingested by the AI tool to implement, to first of all, discover all the features, create tasks for each features, and execute on those tasks autonomously. So what are the goals and objectives? The primary goal, the learning objectives. Important aspect of the document is what's the domain model? You have to describe that accurately. Again, you got to perform your analysis and design practice correctly, the same way we did it as human software engineers, right? Do this well. Again, how well the software product that AI creates depends on how well you describe the software requirements to it without missing any details, right? So we got to analyze all of these information here, understand it, digest it to produce these specifications for our system. So the domain model, I just summarily told it. Otherwise, I would have gone into further details. Again, the more details you give it, the better. But if you don't give it all of the details, it will discover the rest of the details itself. I tell it the four core domain entities are patient. We need a patient object. We need a dentist object. We need a surgery object, which is a location where the surgery will take place, where the dentist will attend to the patient, and then we are making an appointment, right? And yeah, that's sufficient for this demo. What are the API endpoints? We specify that in a list. I just put only one for patient and a couple of them for the appointment. There will be more, right? We need to be able to change an appointment, cancel an appointment, modify an appointment. Yep. What's the technology stack? Technical stack. Tell it what framework we're using, including the version for a case where we want to specifically use Spring Boot version 3. Tell it what what language we're coding in, what build tool we're using, what database, what version, data access layer, what is the framework we're using, JPA. So all of this is knowledge that you, as a software engineer who used to do this by yourself manually, you know, right? So you're now just passing this information across to the AI agentic tool to take it, digest it, and generate features and tasks and execute on the task. Success criteria. Okay, what are the things that it needs to generate tests for and check? It should make sure that it creates all the functionalities work correctly and include error handling, right? Make sure we have test coverage up to 80% for the service layer. So cover all the test cases. Clean separation of concerns. So this is where you are applying your good design principles, your software engineering knowledge to give AI clear instructions to meet the requirement, the specification for a good quality software product at the end of the day, right? And then again, you include a section that says what it should not do, right? It should do all of what you have above. What it should not do, you classify that under a section called what is out of scope for this version, version 1. Don't do the front end. Front end, just do only the API backend for this particular project. Don't include authentication or authorization. Otherwise, we can include it if we want. Don't include email notification. Don't include file upload for photos of the surgery. So these are maybe future features, right? Future functionalities that we can implement later on. But for right now, this is our specification document. This is our product requirement document that we can then pass to Claude Code to execute on. How do we make Claude Code execute on this specification? Simple. You just go ahead and tell it to, hey, discover, right? What are the tasks that you can find from this my specification? But let me go ahead and get the exact prompt that I use from my slides here. So go in here now and, okay, I've already gone past all of this, right? Starting the session, got my session ready, and then tell it to, well, I've already shown about context. I've already shown about system tools. This is what I showed earlier on. And this is where now I tell it to now, please create a list of tasks from my spec.md file. Aha, that's all. So let it go ahead and think through. So create a list of tasks. So you see that idea of task, which I mentioned was just released in the tool recently? It has that built in. And creating tasks is one of the tools that it has. Remember when I showed you the system tools? He has access to those system tools to identify tasks, create tasks, modify tasks, execute tasks. So create a list of tasks from my spec.md file that it will find on the root of the application, right? I don't even have to tell it where it is located. But that's it. Create a list of tasks from my spec.md and watch it do its job. So caramelizing, another fun word that it uses to, to comment on what it is doing. So it says it couldn't find spec.md file in the current working directory. Could you check the file path? You can also provide a full path to the file if it's located somewhere else. No, it's actually on the current working. Let me just verify that, right? So I can ls here to verify that I'm in the right place, but I think I am on the right place. Let me double check that from, yeah, incubating. Anyway, it's gonna find it. Yeah, spec.md was found. Did I spell that correctly? I think I did. I'll create task. Okay, so maybe just give it a little nudge. My ls command here has had it actually recheck the file system and discover the spec.md. So initially it was wrong to say you couldn't find it. No, you can find it. Check the file system. It's on the current. So you can see. You could put it anywhere like you can imagine, like you notice, right? But typically, more ideally, you want to put it in the root of the project, right? So let it be in the current working directory where you're executing your prompt. Okay, but see what it does, right? It discovers 9 tasks. And first task is, it will create the domain entities. And based on my specification, I say, let's have a patient entity, dentist entity, surgery, and appointment. And then it will configure a MySQL 8 database, again, based on my specification. That's what I told you my technology stack includes. I want to use MySQL database and version 8. It knows that it needs to actually work with the Spring framework, Spring Boot, Spring Data JPA. Therefore, it will use repository pattern, right? All of these are things that it is discovering based on my specification right here. My technology stack, for example, tells it that I want to use this framework for my data persistence, data access. Therefore, it decides to use repositories. And I tell it to structure using the best practices for Spring, if you notice. So clean separation of concerns, following best practices for Spring application. It knows what to do, and it's done that, right? Or it's planned to do that. It has not done the things yet, right? So when we look at that, again, we're happy with the task that it has identified. It's covered all the things that we wanted to do and all the endpoints. We can tell it now to start implementing from task number 1. Execute that. So it begins implementation of those tasks, right? And implementing the various features that are part of the task. So the endpoint APIs and structuring the code correctly, all of that should happen. And as it goes along, Yeah. It sees what is already in place. It does not have to redo that, right? The POM file is already there. The POM file already contains my dependencies. And if it's missing some dependency, then it will go ahead and add that, right? But my POM file contains all my framework dependencies that I need for the project. Like I mentioned, I took the liberty to create the project ahead of time. Otherwise, I could have asked it to, it would have included in its task, scaffolding and initializing a new Spring Boot project from scratch if it was an empty directory. But I gave it a directory that already contained a pre-generated project, a pre-created project. Therefore, it goes ahead and works with that. Okay, let's look at the log and see what it has done and supervise it. Again, this is your job. You just want to look over what he has done, confirm that things are good, correct anything that requires correcting, right? But that's the entity class for patient. That's the entity class for dentist. Alrighty. And it puts out the specification, right? A summary of what. And remember, I didn't tell it the fields for each class. So it has used its own discretion to come up with what data attributes and data fields a typical patient class will need. First name, last name, date of birth, phone, email, right? I let it use its discretion. Otherwise, much better in a real world project will be include that in the specification. So where I specify the domain entities, I need to say, hey, patient will have first name, last name, patient ID, email address, and things like that. But I'm happy with what the discretion come up with, right? These fields are good with me. Dentist, you have first name, last name, specialization, surgery name, address, and phone number of the location, and then appointment date, the patient who the appointment is for. It's in foreign key relationship. You can say, so the entity relationships are all good. And I don't like the fact that it doesn't have appointment time. Okay, so we might have to fix that. Tell you that, hey, appointment date is not sufficient. Or let me confirm that in the code. So if I bring up the IDE and just double check that the appointment class, is this truly missing the appointment time? If it is, then that's no good. We want appointment time to be added there. Alrighty. So the last one that I did it. Oh, no, I see what he has done, which may be okay for our purpose, right? So this appointment date field is using the data type local date time. That's fine. So local date time in Java covers both the date and the time. So that covers all the bases. But that's the first task done. Continue with the remaining tasks? I think yes. So give it that prompt. Let it continue with the remaining tasks, 2, 3, 4, all the way to task number 9. Pretty much doing the entire system as we specified it in our product specification. So it creates the database database configuration, right? The data source configuration. That's task number 2. It's done that and it's crossed it out of its list. And then it starts creating the JPA repositories, right? The repository interface and classes. Alrighty. And it knows it's going to make 4 of them, right? Patient repository, dentist repository, appointment repository, and surgery repository for data access operations to the various DB tables. So let's let it cook. So while that's going, let's see. I can show on the slides. I know we're coming 7 minutes over our 1 hour. Just about enough time. So if I bring up my slides here, yeah, I just took the liberty to show the slides for the previous version that I did. And if you notice, it went about it slightly different from what I'm actually doing in the presentation now, right? Initially, when I did my pre-demo, okay, it did not notice that I already had bootstrapped a Spring Boot version 3 Maven project. So it was planning to do that as its first task. But if you notice that after I've actually presented it the list of the content of the directory, it found out that it didn't have to do that. So it skipped that. That was in my pre-demo. But in this, my live demo now, yep, it's done it all correctly without needing to make a new Spring Boot project. Again, we supervise and check for things like that, right? Yep, it's done all the tasks now. Error handling. So we can take a look at the code, all of the source file that got generated. So I already looked at appointment. Let me look at dentist. Look at patient. Look at surgery. Again, I'm aware that not all of us know this technology, right? We're going to study this technology in software engineering and also in EA. But Spring Framework, yeah, using JPA, Java Persistence API, yeah, all of this looks good. This is what would have written all manually or generated with generative AI. But validation is included, right? Remember we said validation? So make sure that you cannot have a surgery where there's no name. Name cannot be blank. There must be a name. Automatically generate IDs for the surgery. Same thing for the patient. Auto-generate. So these are all standard, and that's the purpose of agentic or AI-generated code, right? All of this code is boilerplate. You just have to be copying and pasting the next time you want to work on another project with the same technology. So no need for a human to be writing this kind of code anymore. Generate it all day long. Let's take a look at the repository interfaces. So we got the patient repository, and we got the dentist repository and appointment repository, and yeah, all that looks good. Interface extends JPA repository, perfect. And then the one service class, or what the service classes here. So let's take a look at the patient service. The patient service implement displaying all the list of patients for the purpose of creating that endpoint, right? We check that in the controller. Find a patient by ID. What about appointment service? Get all the appointments and make a new appointment, book an appointment right here. Alrighty, good. Now let's look at the endpoints implemented code for the controller classes. Let me expand that. So beginning with the patient controller here, yeah, it has an endpoint for returning a list of patients. So /API/patients will do that. It's got an endpoint for booking a new appointment right here. Book an appointment. Make sure you validate. And it takes the appointment entity as the request. Okay, there's something that it hasn't done here that as human engineer, we will know that, no, we want to do this better, right? Or maybe, again, everything that it didn't do correctly, it's quite likely that you take that on board, and it's a case of remembering to include that in your specification in future, right? Or update your specification and have it regenerate everything again, or just have it fix only that one issue. But I don't think, let me check my specification once again, that I didn't tell it to use data transfer objects to actually pick up input like an appointment request. So that could be something worth considering doing, right? So where I say, hey, how it should do things, I should include that it should use DTOs, right? So it's another option to include here that, hey, let it use a good best practice like use data transfer objects, right, for requests and response objects. Always, and that's actually the rule of thumb, the best practice for enterprise application, Spring Boot, even .NET, use data transfer objects. Do not expose your entity types directly, because that's what he has done in my controller. Is taking the entity object, the entity class as the input. Look at that in that method. Oh, it's taking the appointment from the entity class, entity package. No, we want to use a data transfer object. Now, I noticed my previous instance, like in my pre-demo, it did it correctly, right? Even without me actually instructing it. But that's where the question comes in again, that is AI perfect? Does it do a perfect solution for you, a perfect software application? The answer is no, it doesn't. It does the majority of the basic things. That's why we still require the human in the loop. The human engineer still has a job to come in and supervise it and correct any omissions, right? And fix any little things that are requiring fixing. But that's pretty much the height of it, that, hey, it actually defines this set of tasks based on just being given a specification document for a software product. And if I could show in this my slide, I'm showing that when it creates those tasks are simple text JSON files. So it stores them in your user directory, Claude directory. Let me go there here on my local machine. So if you go to your, the computer is trying. Go to, on Windows, you find your home directory, user home, right? What user that you're logged on. You will find a special .claude folder. This is where Claude keeps all of his working artifacts. One of the locations here is the tasks. And the one that is most recently created today, look at that, that was yesterday. Open this and you see those 9 tasks. Okay, as it's done them, it's actually erased them all out, right? And I think so even the one yesterday has been erased. But when he generated the task, at the point where he has generated the task and you look through the task, you could have come to a folder in here like this and seen a bunch of these JSON files, right? So 1.json, task number 1, 2.json. And if you open each one, you will see how a task is defined. A task is an object that contains, hey, what other task is dependent on, right? Which one is blocking, which one is being blocked by, because tasks have to be prioritized, right? in terms of the sequential order in which they'll be executed. And it does all that, and it stores all of that information as a JSON object in a JSON file. Alrighty. So the rest of my slides here is just wrapping up what got produced, what I just demonstrated, right, in real time there. So we got a full working Spring Boot project with all the tasks implemented in code. And again, the last part that says you're free to execute the test, which we can go ahead and do that. Yeah, run the tests. And running the test, if we look at the test, again, remember we told it to add tests, right? Automated tests for the implementation of all the code that it has implemented. And we can check out the test code in the test folder here. And we told it to test at least 80% coverage of the service class methods. So let's take a look at, for example, appointment service test. It's going to have to test and make sure that can they create a new appointment. So find all, can you return all the appointments that are in the system? Alrighty, so that's a test. So we can execute this test and make sure that, hey, they all pass for us to say that, hey, the functionalities that have been implemented are working correctly, right? Again, what does it take to execute this test? It means we need to make available the resources that they need. But let me go ahead and do that. So try to execute this test, run the test, and I can predict that it will run into one issue that I know I don't have in place. I need to have a running database server. I don't have that. It's not going to be able to connect. And I need to have access to the database. So I need to fill in those missing information in the project for it to be able to execute, to run the project successfully. So first thing is to start my MySQL database, which I don't think I have that running here. Start MySQL database, create a application user for it, for this application, appointment management user, and then populate my configuration, data source configuration file here with the information. So I need to go to my Spring resources folder. Yep, Maven folder resources, application YAML. So it has some dummy data here for the data source. No, most times I don't want to use root. I will make a special user, put the information here, make a special password, put the information here. Anyways, so just predicting that it will run into runtime issue like this because there's no database, right? And it will discover that, like you can see, and it will tell you, I can't run because, well, it's still checking. There's no database and all of that good stuff that we can intervene as human engineers and fix all of that. Right? Compiles, but cannot run. I don't think he has tried to run. He has just built. So build successful, right? Build a executable jar, now trying to run and then execute the test. Alrighty, updated the POM with Surefire plugins to adjust the memory already. Anyway, it will encounter database not available issue. That's fine. So no need to even watch it do that. But that's pretty much my presentation for, let's see, we started at 3 o'clock, 3:30, 4:30, almost 2 hours. Okay. But at this point, I'll be happy to take questions. Oof, if my computer does not totally give up, it hasn't given up. Thank God, it's still there. Let's go. So the rest of my slides just got up to the point where it's running a test and it's not able to start because you require database credentials. And that's what you see here. Actually, this was still executing. Yeah. So update credentials to run the application, right? Update the database credentials. And that's what you see on my slides here. And thank you, everybody, and best wishes. That's my email. If you require any of these resources, like the slides, I can make the slides available to you guys. The video that's recorded is available in the cloud. And if I get hold of the URL, I will share that with you guys, again, via email. But for right now, let me take some minutes to answer questions that you may have. I mean, you probably have, if you're new to this tool or you're new to Agentic AI, which is a pretty new thing, you should have lots of questions. So let's give you a chance to ask a few, ask some. Any question? Anybody? Engineers excited about this technology, this idea? Oh, are we here? What?
Yeah, it was amazing. I have a question about it's the Cloudy also able to make the security, Spring security too?
Yes, it can do it all. You see, I excluded that in the scope of my demo. Authentication and authorization using Spring Security, you can include that, of course. All of that is boilerplate code. Whenever it's boilerplate code, agent will do it, right? Just give it the specification and it'll do it. Yes, it can do Spring Security. And I know the curiosity, maybe you're into Spring. Spring Security can be hard. Is that correct? Is that true? I think
Yeah,
so too. Spring
yeah,
Security is one of the complex modules in Spring, but we're going to learn that inside out in software engineering so that whatever Claude is able to do, we need to be able to do as well and even better, right? So we make it do the boring, time-consuming thing, and then we supervise that he has done it correctly and it works correctly. So we will study Spring. So the question is, do you still need to know how to code Spring? Yes. Do you still need to know how
yeah.
to code Java? The answer from me is yes, because we are
Very
still serving
commodified.
as the supervisor to review the product of AI agents, right? AI will produce something. We need to be able to look it over and give a thumbs up or gives a thumbs down and correct something that needs correcting. So you need to learn your design patterns, architecture. You need to learn your Java language features. You know, it can use the wrong pattern or the wrong construct to implement some certain feature in the code. Okay, we need to identify that that's the wrong construct. Don't do it with for loop. Rather, make it functional programming. Use a stream API, right? So the stuff that you're going to learn in FPP, computer science fundamentals of data structures and algorithm, still very relevant, even more so now, right? The stuff that you're going to learn in MPP, advanced Java stream processing and functional programming, still very relevant. You still need to know those things so that when AI does what it does, we need to be able to supervise it. Makes sense? So the software engineering degree, still necessary. The computer science degree, still necessary, still relevant. And by the way, it's computer science knowledge that's creating these tools. In a future lesson, we'll cover how to actually create our own agents, right? Using agent creation frameworks like LangChain and LangGraph. Alrighty. Any more questions? Go ahead. A second person has another question. Go ahead.
I want to ask that for a last code base,
Mhm.
and when working with last code base, what I encounter the most is that the agent tend to forget the previous form when we are doing a long section. So any strategy you can deal with that?
Good. I think that question falls under there, the topic of session context management, right? When you have the larger your code base means Claude needs to keep track of a lot of information, right? If you look at the Claude code documentation website, depending on what subscription level that you sign up for, the pro edition that I have has a limit of the session context to be 200K, right? Which is about, should we say, about 50 pages of content. So for a large code base, you can actually have lots of source code file that goes beyond 50 pages of content. In that case, you want to be able to manage your context carefully such that you give it context to work on a small feature. Once you finish that feature or a given task, you clear the context before you start a new task, right? So that kind of techniques, various techniques for context management will help you to actually successfully work, effectively work on a large code base. Otherwise, again, a large code base can actually also have an issue with the architecture. Those are bigger things where human engineer wants to come in, right? It's not a smart idea to have a banking system that has 50 pages of content, right? Why don't we break down this banking system into small services so you do away with, you avoid having large code bases, excessively large code bases, by breaking this large banking system for Bank of America to small microservices for customer management, account management, loan management, or loan tracking or payments, right? So modularize your application solution at the architecture level, right? You have the right small microservices, then you can avoid loading a large code base to as a project, right? The project becomes, instead of one big project, multiple smaller project. Make sense? So you can see we solve the problem even before we bring in the Claude AI to help us do that with our architecture thinking and our little basic principles that we apply, best practices too. But excellent question.
Thank you for your answer.
I was concluded the meeting by saying, thank you for your time. And I showed my email once again on this last slide here, that if you have any additional questions offline after we're done with the meeting and you actually want to ask, you can email me or you can chat me using Microsoft Teams as well, Teams chat. But I highly encourage you to get started working with these tools, right? Yep, they'll become our primary tool, and your aim is to become an AI native software engineer And yeah, that is actually the state of the practice as of today, and it's going to continue evolving. So, and I hope while I was answering I think I took 3 or 4 questions, you guys could still hear me. Not sure whether we missed anything there because I went offline, my computer froze and went offline for a minute. But that concludes the presentation, everyone, at 5:27 here. So we've gone for about almost 2 hours. So thank you for your time, everyone. I'll go ahead and end the meeting now, and I will share the recorded video link once I have it available, okay? Thank you, and I'll end this meeting. Let's go ahead and